All right, so final trend is metallic character. So if we think back to the beginning of the class and what we said a kind of metallic bond was, we said it was this kind of sea of electrons where basically the electrons don't particularly belong to one element, they're just kind of floating around. And so all of these electrons are very loosely bound. And that's kind of the main principle of a metal, is that it has very loosely bound electrons. So if you think about kind of what a metal is, they're good conductors of electricity / heat. So if you want to be able to conduct electrons, they got to be loosely bound, so that way they can move around the place. They're malleable and ductile, which means that we can basically move them into sheets, make them into wires, all kinds of stuff. And again, that kind of makes sense because these electrons are very loosely bound, so these atoms are free to move around. They're shiny, and they generally lose electrons in reactions. So pretty much all of these things kind of, again, demonstrate that these electrons are very loosely bound. So if we think about our periodic table, remember we have the staircase somewhere around here, and we said everything kind of to the left of this staircase is, for the most part, a metal, and then everything to the right of the staircase is a non-metal. So metallic character generally going from left to right and from bottom to top, less metallic, and vice versa for the other one. And all of this makes more sense, right? The more we get to this bottom left electrons or bottom left element, the bigger atom that we get, and then we also get a lower Z effective, right? And so big atom, electron very far from the nucleus, low Z effective, the electron is feeling a very weak pull. All of these are going to be easy to remove. Or loosely bound, right? And we said the requirement for our metallic compounds are that they have loosely bound electrons. And then vice versa for this non-metal side, over here they're going to be small and they're going to have a high Z effective. And so overall it's going to be very hard to remove these electrons, and they're not going to be loosely bound. So it's nice how this kind of sums up a good bit of the trends.